Now, what I'd like to see in your papers, so as you are working, let's stop and go back and maybe put some more stuff in. I'd like to see some work, and that is that you're going to add 1 to the exponent and that you're going to divide by the new exponent. That's the work that shows me you're not just pushing a button on the Inspire. You can rewrite this as x to the negative 2 dx plus the integral of 2x to the negative 3 dx minus the integral of 3x to the negative 4. You can do that. Now, what most of us do is just mentally, it's like with a derivative, we could write it as and I have had you do this at times with some of those rules, as an individual derivative of each term. But generally, especially with the polynomial, we just take it we know that we're taking it of each term. So you can, if you want, write it out individually. So I've got, I add 1 to the exponent, divide by the new exponent. I add 1 to the exponent, divide by the new exponent. I add 1 to the exponent, divide by the new exponent, and I don't forget to put the constant of integration. Now, when we do this, we're no longer finding the end. We're no longer using the integration. What is this now? If this was the derivative, this is now the antiderivative, or the function that generates that derivative. Okay, so keep that in mind. This is our function f of x now. So let's see, we've got x to the negative 1 divided by negative 1, so I'll make it negative x to the negative 1. This is going to be plus 2x to the negative 2 divided by negative 2. That's also going to be negative 1. Minus 3x to the negative 3 divide by negative 3, so that will actually become a positive term there. We'll put a little equals out there. So equals, and this would be 1 divided by x, minus 1 divided by x squared, plus 1 divided by x cubed, plus c, and that is our function. Did I make an error on that? Yeah, I did. I made my equal sign so close I forgot to pick that up. Thank you, Jennifer. How would we check this? Take the derivative. Now, you might want to say, well, let me write it this way first. This would be probably the way you'd start it anyway to take the derivative. Okay, so we've got section 5.1, and basically that's what we have in section 5.1. You need to practice that. There's one thing I want to bring out to you, and that are, I don't know if it's 61 or not, but problems like this. Solve the differential equation. This is the second derivative. This is the first derivative that has some information. I know that when the input's 8, the output is 6, and this now is the function that when the input is 0, the output is also 0. So if I want to solve the differential equation, that's the same thing as saying find f of x. Okay, find f of x. I give you the second derivative. Now, in order to find the second derivative, if you know what f of x is, to find the second derivative, you have to first take the first derivative. Okay, so if I'm going to work on this, I'm going to have to, and what we're going to do is take the indefinite integral of x to the negative 2/3 dx. Remember now, this is the second derivative, and my answer is going to be what? The first derivative. Okay, so let's see. I apply my rule, negative 2/3 plus 1, divide by, put that down a little bit, divide by my new exponent, plus c. So let's see. Negative 2/3 plus 1 is 1/3 divided by 1/3 plus c. So this is the same thing. Divide by a fraction, you multiply by the reciprocal. Okay, so I know that my first derivative is 3x to the 1/3 power plus c. So the first thing we do is take the indefinite integral of the second derivative to give us the first derivative. Now, I know something about this first derivative. I know that when the input is 8, the output is 6. When the input is 8, the output is 6, so I have 3 times 8 to the 1/3 power plus c. 1/3 power, otherwise known as cube root. Okay, so what is the cube root of 8? 2. If that's true, what's the value of c? 0. So now what I know is, I know that the first derivative is actually just 3x to the 1/3 power plus 0, or simply 3x to the 1/3 power. So the first thing was to take the integral. The second thing is to put that information in about the first derivative. I'm trying to find what? The function, okay. So now in order to find the function, if I know the first derivative, can I find the function? Yes. How would I do that? Take the indefinite integral of my first derivative. Okay, so this is my first derivative, and when I get an answer from that, it is going to give me the function. Okay, so I've got 3x, just use the rule, add 1 and divide by the new exponent plus c. So let's see, 3x to the 4/3 divide by 4/3 plus c. That's the same thing as divide by a fraction, multiply by the reciprocal. Okay, or 4x to the 4/3 plus c. And this is what now? F of x. Okay. Do I know anything special about the function? Yes. I know that if the input is 0, the output is 0. So let's go down here. Let's go down here and stay there. There we go. Okay. So I know that f of 0 is 0, which means that 4 times 0 to the 4/3 power plus c is also 0, which tells me what is that constant? 0. So what is my function? Okay. There we go. Or you could do lots of things. 4x, the cube root of x, whatever you want to do with that. Okay, so now we have a definite one. Well, I do want to give you this quiz. I'm also tempted just to continue lecturing, but I think I'll give you the quiz instead. Because you've studied, right? You're ready to go with this. Okay, good. That sounds good. Now, the deal is, though, as much as